Advanced Math Lesson 28. Part A is factorial notation. Don't they look exciting? Okay, so you see here a 5 with an exclamation mark. That is red. 5 factorial. I suggest writing that at some point. I'll just point it to this one. That is 5 factorial. Okay, and it means the product of 5 and all the natural numbers that are less than 5. So it's like you're counting down and then you multiply all of them. 5, 4, 3, 2, 1. All as factors. So you multiply them, and for that one, that's 120. And there's a note over here. Factorials are used a lot when working with probability problems. So this part of the lesson is just kind of getting you ready to use that notation. We'll just get some practice with it. So here's your general formula. X factorial is x times the number that's 1 less than x times the number that's 2 less than x, all the way down to 1. And so then here we have some examples of simplifying some expressions that have factorials in them. Alright, so this is 9 factorial is 9, 8, 7, 6, 5, 4, 3, 2, 1. Alright, then on the bottom we have 3, 2, 1 for 3 factorial times 5, 4, 3, 2, 1. Reduce, 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 reduce. And so what we have left, this will still reduce more, but I want to point out we could have split this 9 factorial into 9 times 8 times 7 times 6 times 5 factorial, because I knew that 5 factorial would cancel with this bottom 5 factorial. And that's a shortcut you can use just to keep your work a little bit more compressed, more simplified. Alright, so now I have 3 times 2 equals 6, so that reduces. And then you just go ahead and multiply 9 times 8 times 7, and you should get 504 for that. It's over 1. Do not write it over 1. That technically is an improper fraction, and it's not necessary. Simplify that. Okay, next one, I'm going to use that shortcut I mentioned. So 14 factorial. I look here at the largest one of these I have. This is what I'm going to take this down to. 14 times 13 times 12 times 11 factorial, because it will cancel with that 11 factorial. So 6 factorial. 6, 5, 4, 3, 2, 1 times 11 factorial. Those cancel. And then we reduce things, or just get your calculator and solve it. But actually, this one's not going to come out even. We're just going to reduce this. 2 times 6 is 12. So there we go. And I'm not seeing anything else except these 2 evens. So we can do, whoops, that's not right. There, 7. Okay, so we have 7 times 13 in the numerator, because it's 91. And then here we have 5 times 2, which is 10, times 3, so 30 in the denominator, and that will not reduce further, and that is our answer. And now we're moving on to part B, which is abstract rate problems. You've been doing rate problems since, well, I think Algebra 1, and they've always had numbers. Now you'll see very few numbers in these problems. That's why they're called abstract. But it's still distance, rate, and time problems. You set them up and simplify, solve them like normal. Alright, so here in example 2, sorry, that should have been a 3. I had added one to the top part. Here's a 3 and a 4. Okay. The train traveled m miles at p miles per hour and still arrived 1 hour late. How fast should it have traveled to have arrived on time? Okay, so I set up our columns for what happened and what should have happened. So it did travel a distance of m miles at p miles per hour. That would be a rate. Okay, we'll deal with that 1 hour late thing momentarily. We know distance equals rate times time. Okay, so to find this time, we're going to get this by itself. Okay, so divide both sides by r, that would be time. So this time is this distance divided by this rate. So m over p. Okay, now it's still making the same trip. What should have happened would have been still m miles. We're finding R2, how fast should it have gone, to have arrived on time. So here's how long it took. It was an hour late. We need this time to be 1 hour less so that it's not late. It needs to take 1 less hour to get there. Okay? So then that means, again, distance equals rate times time. So to find the rate, we have to divide the distance by the time. So how we get the answer is d2, which is m, divided by, I should put r2 equals, the time. Okay, and I'd like to write this as one fraction, because I'm going to have this complex fraction I need to simplify. So this okay, so I just here change 1 to p over p. So this is m minus p over p. And to simplify a complex fraction like this, this is m divided by this fraction. When you're dividing by a fraction, you multiply by its reciprocal. So what we're really going to do is take m times p over m minus p. And it doesn't reduce or anything. So R2, the rate it should have gone, is MP over M minus P. Don't forget your units. Miles per hour. Okay, for your notes, you want to maybe show another step, so that you know the process when you're looking back at your notes to do these problems. But again, they are solved the way we've been solving them, and you simplify a complex fraction the way we've been simplifying complex fractions. So it's just putting some things together you've already been doing. Let's take a look here at example 4 as our last example. It's a short lesson. The boat traveled k miles in t hours and was 40 miles short of the goal when the gun went off. They must be having a race. If the skipper tried again, how long would it take to reach the goal if she increased the rate of travel by 10 miles per hour? Okay, so last time, k miles, that's the distance, t hours, that's the time. Okay, pause there. What's the rate? That would be distance divided by time, like it was up in the previous example. So this rate is k over t. Okay, it was 40 miles short of the goal. If the skipper tried again, how long would it take to reach the goal? Okay, the distance was 40 short, so now the distance is going to be k plus another 40 miles, because reaching the goal. Okay, so, and she's increasing the rate by 10, so it's this rate plus 10, and then we're going to find out how long it would take. We're going to find the time. Alright, so again, distance equals rate times time, and we have from the previous example over here, time is distance divided by rate, so we need to divide d2 by r2. And we're again going to need that R2 to be one fraction. So I'm going to do that right here. I would need t over t times this one. So this rate is k plus 10t over t. So to find the time, let's go down here, t2 equals d2 over r2. So that's k plus 40 over this, k plus 10t over t. And again, to simplify a complex fraction, we multiply the numerator by the reciprocal of the denominator. So we have k plus 40 times t over k plus 10t. Make sure I copy that correctly. T, k plus 10t. Okay, and nothing reduces on this one either. And I think I'll distribute. So we have kt plus 40t over k plus 10t. This is time. It's hours. And that is all there is to that. Hopefully you enjoy these problems.